So today is the start of the second portion of the shadowing program, which is code. So we're going to go over some basic, in general topics that's best to cover, and then later on we'll be going into the coding part. But to do that, we need to cover some simple mechanical part, as we need to understand what we're going to code in the first place. So, as you know, I'm part of the FTC Ink and Metal 5773 team, and we're part of the First Tech Challenge. And First is pretty much a robotics organization that hosts competitions and events in order to draw attention to robotics as a whole. So there's three parts. There's three events, as you might say. First LEGO League, First Tech Challenge is what I'm in, and First Robotics Competition. So right now we're going to be talking about FTC using that as an example. So it has to be software and hardware understanding, computer-aided design, which is called CADing, and software skill, and task management if in a leading position. FTC is a middle competition in series, FLL, FTC, and FRC. And the robot game changes yearly, so you can't just use the exact same robot year after year. So this is a robot from last year. Please mute, unless you're asking questions. So this is our robot from last year. So as you see, it knocks down, uses the rings to knock down 3 power shots over here. It's kind of hard to see, but pretty much each of those gives you points, and as you know, in the time period, you have to collect as many points as possible. So these 30 seconds would be called our autonomous period, which is purely code, and you can't control where the robot goes. And our FTC robot uses Roadrunner libraries, which is a software program that we'll talk later. And this would be our type of program that we use. Some hardware would be servers, sensors, motors, and we use GoBuilder and Rev for our build system. So when you have a robot project, it doesn't have to be FTC as a whole. So first you have to define the problem. So for example, in the ultimate goal season, in the game with the intake and shoot ring, and the mechanisms would be grip rollers, flywheel, and ring carriage.
Yes.
So as you can see, so you scroll over here, it intakes the rings. I'll play it again. And using a servo and motor, it aligns and shoots at the goal. The second step would be to generate concepts. So pretty much get ideas. So at least what we did is we have each team member to sketch an idea, right? And have it precise. And so pretty much we hold a meeting after that, discussing all of them. For example, this one over here is our chassis, which is the base, as you probably learned in the previous session, where pretty much has the structure of a robot. Everything else will be built on top of it. So it needs to be sturdy to hold the robot, and it has to be also fast, and of course it has to be structurally sound if there's enough space. And here's a surgical tubing, which is another mechanism of input. And again, if you notice, we didn't use that, which is okay. Many people get ideas, only a couple of them will be used. Here's another type of idea, and this is also another type. So once we choose solution, the next step is to CAD it, or to pretty much 3D design. So we use a lot of different software such as Autodesk, Fusion 360, or Inventor UI. UI. And then SolidWorks and Onshape is two other things that we use. So if you look at it in the last, so you see this is the chassis design that we thought of, and this is how it ended. So now this has a precise measurement. So we can, once it's the CADing is done, we can exactly replicate it, making it easier to look back and check as needed. And if the last step, one of the last steps, but in the one of the later steps at least, would be building it. However, the reason it's not the last step is you got to make sure it works, and the best way is to evaluate. So you see all the problems in person, it's pretty much just trial and error, and seeing it like, okay, for example, input is not as efficient. And that way we can go back if necessary and go back to this step to generate more concepts. And then the final solution. So this is the entire thing last year. I'm going to pause right now so you guys can read it.
Well done.
I'm just going to wait a couple more minutes for some people who are slow readers. Okay, so let's move on. So now, so you can just type in the chat when you got your answer, and don't copy anyone else. But the problem is, right? Let's make a sample problem, right? So we have a lot of cross contamination of trash, meaning that some trash goes into recycling when they're not supposed to, or the opposite. So we have built the mechanized trash sorter to scan and detect waste, and then compost it or recycle it or put it in the landfill. So if you have an iPhone, you can download the InstaSort app, and you can see a solution in greater detail. And once we release the app in Play Store. So now, right now, think of a problem that negatively affects the world, and try to create a solution for it that's viable. And 3 factors: cost, feasibility, and effectiveness. So I'm gonna give you around maybe 10 to 15 minutes just to think about it and type in the chat. And try to do it in detail, as in give the target audience, around the experimental cost, and some other factors that might play a role. And also think of some factors like feasibility, as that plays a role. For example, there's many solutions to many problems. However, they're not that feasible in many ways. One, maybe space could be a problem. It could be about, like, in general, who would actually do that? Would people actually believe in that would be the right thing to do? Or, of course, money. Is that a factor? So that is all important things that you have to consider. So write in detail about, for example, what exactly would be a solution, right? About the problem, and try to explain. That's why I'm giving you 10 to 15 minutes, and try to explain. So for example, this is for the trash sorter, right? It would be like cross contamination is a big problem as it causes a lot of things that could be recycled to not be recycled, meaning many resources would be wasted and the landfills would increase, causing a lot of animals to die, and of course the world in general become worse because of global warming and other stuff like that. And a solution to that would be the trash sorter. To have as cheap as possible, so this would be around $500, to create some public place where people can input their trash and use an app to see if it's either recycling, compost, or trash. Um, Samir, that's a good idea. All right, so that would be an example one. You can build off on that more. And just FYI, it doesn't have to be exactly about trash. It could be about anything. It could be about waste of water. It could be about um about the food crisis. It could be about anything that plagues the world today. people who just joined, so we'll be spending around 5 more minutes on this to think of a problem that negatively affects this world and try to find a solution that you can brainstorm. Some factors is cost, feasibility, and effectiveness. Some, for example, a good example that Mir gave, be an environmental awareness app that gives tips that helps users or lower impact on the environment and use resources efficiently, giving content such as, for example, probably a good idea would be like if you use a lot of plastic, then they would give some brands that nearby that would help decrease the plastic or is more recycled plastic, which reduces its impact on the climate. So just type in the chat what you think. And again, cost, feasibility, and effectiveness are very important in these factors. So what I just said is just for the newcomers. I just explained them to think of some solutions and brainstorming. We're gonna start again in 3 minutes. Okay, so let's get started now. So how can we tell where a robot is on a field? So this would be one way to do it, is an encoder. So pretty much it's going to be embedded into the motor, as there's and some parts needed. There's a photodetector, of course, a circuit board, a disc with dark lines, so like tick marks, a light source, and wire to connect the motor and the control hub. And just for people who weren't there last couple of days, the control hub is pretty much the main brain of the robot, as you might think, and where the drivers have access and control the robot from. As the motor rotates, lines pass in front of the light source, making a tick, and is caught by the photodetector. The ticks to unit distance ratio, so pretty much this helps figure out the distance, and this way it can measure, for example, at a starting point, if it's 10 ticks, then the measurement of a tick per the motor is already previously calibrated, and with that you can figure out the distance, and then you can figure out where the robot is. So some disadvantages is it can only be used in accurate motion, and it cannot be really determined position if it's more of a complicated route. And it can be built in common motors, it can be applied in outtake, and of course acceleration is a lot more consistent. So an odometer is pretty much an encoder casing plus an omni wheel. So 3 odometers is placed in the diagram as the robot moves, and they capture movement and send it to the control hub. And the starting point is the origin, and the target position is specified as a coordinate. Some disadvantage is the tuning is very time consuming. It's very delicate. Or also get inconsistent readings. Returns exact location on the field, very useful. And no need to write the code from scratch, as it's already partly there. And many teams have released odometry modules for any team to use. So a distance sensor is pretty much an emitter and receiver. And so a beam of light or a wave of sound is emitted and bounces off the object until the return is recorded. So you can use E is equal to RT divided by 2 to determine the distance to the object, and can be used with odometers or encoders to help increase the accuracy. So that's it for today. But for the people who came late, we're going to go over the beginning, as this part is very important. So when you have a robot project, there are specific steps that definitely need to be used to help pretty much establish the process to make it even better, and making the process as clean as possible, helping the robot get fast, helping the process become faster, more efficient, and have a better end product. First, define the problem. For example, in intake, for the last year's season, intake and shooting rings were not really the problem, but our goal. So this is, for example, mechanisms we came up with. So the mechanisms, as you can see, is a grippy roller over here. Over here, it's kind of hard to see, but there's a ring carriage and there's a flywheel. I'll display it one more time. Let's go on to the next one. No. Generating concepts. Very important. Pretty much the main part of generating concepts comes with pretty much getting everyone to get some form of ideas. It doesn't have to be good, doesn't have to be bad. It just has to be an idea that you can build off of or help support other ideas. For example, these are some previous ones. If you look over here, this is our previous chassis sketch. And later on, once you choose a solution, it can be CADed. As over here, this is the exact same chassis with CADed. Some software is Autodesk, Fusion 360, SolidWorks, Autodesk Inventor, and Onshape. So then you build a solution, evaluate solution. So now, as most projects, something will go wrong with them. Then you have to go back to the solution and figure out a way to help prevent that. And at the end, present the final solution. So again, if people are late, you can read through it. And thank you for attending this class. And again, tomorrow will be our next session, and of course, our last session. I will probably be your mentor for that one too. So thank you, and see you